Hello. Today I will discuss how to perform regression analysis in SPSS. We deal with the person's height data with only 10 observations. Using this data set, we want to predict adult son's height based on father's height. We select Analyze, then Regression and then Linear. This will open a dialog box. Here we need to select List of independent variables. As we want to predict adult son's height based on father's height is the independent variable in this context. As adult son's weight is what we ultimately want to predict, this variable is selected as a dependent variable. Let us take a look at the default statistics options. Notice that regression coefficient estimate and model fit is already selected. We press Continue to go back to previous dialog and press OK. This will open up output window. The first table provides a list of independent variables includes or removed. Here father's height was the only variable entered. Next table shows model summary such as correlation and R-squared estimates. The following table in an Anova table. The final table includes the list of estimated coefficients, such as intercept as well as slope of the father's height variable. Other statistics that are frequently of interest are the 95% confidence intervals of the slope as well as the correlation matrix. To obtain them, we again select Analyze, then Linear Regression. This time we select confidence intervals and correlation matrix options from the statistics menu. We can also select descriptive statistics option to get the mean and standard deviation of the dependent and independent variables. In the output window, you now can see the descriptive statistics table at first. The correlation matrix is printed next. In the coefficients table, you can see the 95% confidence intervals for the slope and the intercept. We should always check whether the fit violates the assumptions of the independence of the errors, normality of errors, linearity and homoscedasticity. To check them, we need to draw the scatter plot of the standardized residuals versus standardized predicted values. One other plot that is popularly checked is the scatter plot of studentized residuals versus standardized predicted values. To plot these, we again open the linear regression dialog from the Analyze menu. In the Plots option, we select SPSS in the x-axis and RESID in the y-axis. In the next option, we choose SPSS in the x-axis and RESID in the y-axis. Choosing these options will produce 4 plots. The first one is a histogram of the standardized residuals. A normal curve is superimposed for us to check whether the standardized residuals follow normality. Next one is the normal PP plot of the standardized residuals. If the points are approximately in the 45 degree, then the standardized residuals should be following a normal distribution. Following is the scatter plot of the standardized residuals versus standardized predicted values. We want to see if any pattern is visible here or the points are randomly scattered. If this plot looks fairly random, then we are okay with independence assumption of the residuals as well as linearity and homoscedasticity assumptions. The last one is the scatter plot of the studentized residuals versus standardized predicted values. The purpose of this plot is mostly identical to the previous one. If we want to save these standardized residuals, studentized residuals and standardized predicted values in the dataset so that we use these variables later, we can also save them from Save option in the Linear Regression dialog box. When we go to Data View, we will see 3 additional columns. In the Variable View, we will be able to see more details about these variables in their corresponding labels. We can simply save this dataset for later use. For example, we can now find descriptive summaries of these variables just like any other variables in the dataset.